Hello, exciting news. We're starting Unit 8 today. Hi. So you can see that Unit 8 is quadratics. Now, we have to do a bit of boring background work today before we get into the good stuff, but I promise eventually this is one of those ones you're going to love, okay? So we're going to just start here and talk a bit about what on earth I even mean whenever I say a quadratic, and then we're going to move into stuff that will maybe seem a little bit random to you, like, oh, she was just talking about these equations, why are we doing this? But I promise it will all come together, okay? So stick with me. Now, so far in equations, we've generally only really looked at linear equations, okay? So if you remember, linear equations are equations which are generally in the form y equals mx plus c. So I suppose they don't even need to be exactly in that, but they could be like 2x plus 1 equals 5. That would also be a linear equation. So in a linear equation, the x term doesn't have a power on it, okay? So it is just an x or a whatever letter it is that we're talking about. In a quadratic equation, oops, I can't even spell. So in a quadratic equation, the term, though there will be an x squared term in it, and generally it is x that's used here, so it could be like x squared plus 4 equals 1. It could be 5x squared minus 10 equals 0. It could be 3x squared plus 2x plus 7 equals 0. Okay? In a quadratic equation, there will always be an x squared term. Now, we are eventually going to be moving on to solving equations like this, okay? And see ones like this. Generally, we would say they're in the form ax squared plus bx plus c. Okay, now yeah, as I say, we are going to go on to solve those eventually, but we do have to get a little bit of practice in just with some of the techniques that we're going to be using in solving this. Okay, so it's some of that stuff that we're going to be looking at here today. So open your notes at page 93, please, and read along with me and fill in stuff that I am filling in here. So this is just our introduction to this whole unit. It'll be a hopefully more succinct way of telling you what's in it than what I have just tried to do. But linear equations do not involve powers of the unknown letter. So like we were saying there, it's just the x on its own. So 2x plus 3 equals 9. Quadratic equations, which is what we are moving on to, have a term involving the square of the unknown letter. Annoyingly, this is like over a line, but for example, x squared plus 5x equals minus 6. Okay, so within this unit, we will eventually be learning how to, first of all, factorize quadratic equations and then solve quadratic equations. Now, if you think back to what factorizing actually means, remember it's just the opposite of multiplying out brackets. So in fact, let me just remind you a wee bit about that. So earlier on this year, we would have been doing things like multiplying out something like that to get 6x plus 2. And then factorizing would have been going backwards. So working our way back from that. So taking something like 9x plus 6 and putting in the bracket. So we would be seeing that 3 could go into both of these terms, and 3 needs to be multiplied by 3x to give me 9x, and 2 to give me 6. So this step is the multiplying out the bracket, and going the opposite way round is factorizing. So what we are going to be able to do by the end of this, if you remember FOIL, so if we had something like x plus 2 and x minus 4, then we would have done some work, or we did do some work earlier on in the year, where we were multiplying out these brackets. So first, x multiplied by x gives me x squared, outer, minus 4 multiplied by x gives me minus 4x, inner, 2 multiplied by x gives me 2x, and last, 2 multiplied by minus 4 gives me minus 8. And then I can tidy these up. So x squared minus 4x plus 2x gives me minus 2x minus 8. So this here was us expanding the brackets. And do you notice what we've ended up here with? Good sentence. We've ended up with a quadratic expression. Now it's not an equation because we haven't said it's equal to anything, but we've ended up with a quadratic expression, and we know that because of this squared term in it. So what we are going to be able to do is work backwards here. So going from here to here was expanding the brackets. We are eventually, not today, but eventually, going to be able to work backwards from a quadratic expression like this, and it will always give us brackets like this, like the double brackets that you use FOIL to multiply out. Okay, so hopefully seeing that will make you realize why we're doing some of the stuff that we are doing today. Otherwise you might think it's completely random. So back to the notes. Page 93, remember? So today we need to be able to substitute values into quadratic expressions and simplify them. So in previous units you have learnt how to, there's a wee H missing, and oh, disaster, learnt how to substitute values into an expression. It's really straightforward what we're starting off with here. Okay, now again, because this says we're substituting values into quadratic expressions, you're probably expecting to see an x squared term or something there, and then all of a sudden I'm giving you this. But remember what I said there about the factorizing? Whenever this is multiplied out, that will give you an expression with an x squared term in it. So this is just like a factorized quadratic expression. Okay, so let's look at example 1. Find the value of x plus 2 multiplied by x minus 4 if in part A x is 7 and in part B x is minus 2. So for part A, first of all, the first thing we need to do always is to write out the question, obviously. Then all we need to do is replace these with the numbers that we've been told. So x is 7, so this is 7 plus 2 and 7 minus 4. 7 plus 2 gives me 9. 7 minus 4 gives me 3, and that just means 9 multiplied by 3, and that gets me 27. So that's the answer to that. That's all we're starting off with, nice and straightforward. So let's look at B. Whenever x is minus 2, again, same expression. So we're doing x plus 2 and x minus 4, and replacing the x with a minus 2. So minus 2 plus 2 and minus 2 minus 4. Minus 2 plus 2 is 0. Minus 2 minus 4 is minus 6. 0 multiplied by minus 6 gives us 0. Now, this example is in here on purpose. This fact here is going to come up a lot in this topic, and it's something that people often forget. Anything multiplied by 0 gives you 0. So if you have two things that are multiplying together and your answer is 0, you know one of the things that you're multiplying by has to be 0. But I am, again, jumping slightly ahead with that bit. Okay, let's look at example 2. Find the value of x plus 3 all squared, and then we've got different values of x. So for part A, x plus 3 squared. All I need to do is replace that x with a 4 for the first one. Gets me 49. And then for B, x equals minus 5. So x plus 3 squared minus 5 plus 3 gives me minus 2 squared. Now be careful. Minus 2 multiplied by minus 2. 2 times 2 gives me 4. A minus multiplied by minus gives me a positive. So my answer here is positive. And again, this example has been put in here to remind us of that fact. that the two negatives multiplied together gives you a positive. So that will come up later on. Now, I was just looking there. I think I'm actually going to split this up into 2 different videos. So I'll tell you what the classwork is here, but I'll also write it in the stream. So it's page 220, exercise 11A. And first of all, now we will be doing more of it after as well, I want you to do questions 1 to 6. So those questions here, or these ones, are very much like these 2 examples, okay? Then, once you've got those done, click on my next video, and that's going to go through the next couple of examples in the notes and get you ready for the next exercise. I just think it's better if we split this into 2. So, for convenience sake, I will link my other video on this here. Okay? Bye.